Okay, so it's climbing up to, that's 3.53 volts. As you can see, this is what we're charging, guys. This is the battery. Just a single lithium-ion battery. And as you can see, as I turn on that, it is actually charging. So, a way to smooth the voltage is just to add a capacitor in parallel with the motor, the generator's terminals. So that's one way to smooth the voltage, make it really smooth without any. Whoa. Okay, as you can see, the voltage is actually increasing, guys. Right. So we're gonna hook up some wires to this capacitor so that we can hook it up to the generator and smooth the voltage. All right, let's do that right away. Okay. Where did I put my pliers? Right. Okay. I'm just gonna take this out for now. So we're gonna peel out the wires and hook it up to the capacitor's terminals so that we can smooth the generator's voltage. So just gonna connect that. I can't solder right now because my soldering iron is bad, so we're just gonna do it the old-fashioned way. Use the stranded wires and then hook it up to the capacitor. Really easy. All right. So if you have any questions, you can just comment down below. All right, so press that right down. And this, hey, how you doing? Odil, what's up? Okay, peel this out and connect. Yeah, Ariel. So what I'm doing is I am wiring this generator to make everything straight and more easier to work with. My World Together says, do you know how to fix electric scooters? Yeah, of course I do. Do you have any bad electric scooter? Do you have a one that needs to be fixed? Or hey, what's up, Tay? All right. Okay, so let's hook this up. So we're using this connector, which has continuity on these lines, and this is not connected. Same thing with this and this. We have a straight line of connection here, here, and here. But at this point, these 2 points right here are not connected. Same with this, same with this. So let's do the connection. It's really simple. It's just, all we need to do is just hook up the capacitor right here, and then the generator goes. Let's see, maybe we can do a loop or something. Oh, I think I'm gonna need the handle for this. All right, so connect this, and all right. So you want to be really sure of how you're connecting this. You want to connect the positive terminal. Hey, what's up, Sticky? What kind of LED factory did we end up in now? Okay, LED factory. I don't get it. LED factory. No, this is okay. I get it. This isn't an LED factory. This is just a setup. This is just a hand crank generator, which I'm gonna use for which I'm gonna use in a bicycle or something to charge phones and a pack of lithium-ion batteries, which I wanna do at the moment. So, Mohammed, hey, what's up? So, I'm setting this up so I'm gonna use this guy to charge about 10 lithium-ion batteries in parallel. So, yeah, this is what it is. This guy is a beast, really powerful. 40 volts by just hand crank and 3 amps by just hand crank. So imagine what will happen. Imagine how many volts I'm going to get from this when I hook it up to a bicycle, or when I use blades and let the wind spin it. So yeah, so let's do the connection. Just going to take this. Whoa, this guy's out. Firewire says, how does your generator work? You've made it. All right, so how this guy works is just a really simple setup. Some sets of gears. We have a large gear, and then the large gear has a lot of teeth, and then we have a much smaller gear which has just a few numbers of teeth, and then a much smaller one, which is driven by this part of this gear right here. And then what happens is when you turn on this, it turns the last gear really fast, and then we have a motor that's sitting here. And what happens is when you turn on this, it increases the speed and turns the motor really fast to generate about 40 volts with just hand crank. So in reverse, if we do this in reverse by turning here, we are able to increase the torque, the power of this setup, this gear setup. So as you can see, with just one finger, I'm holding this really strong, but with one finger, I'm able to turn it. As you can see, the power here has been increased. So if you want a greater power, you can do a much larger setup by using a much larger gear. And yeah, so you're going to get a much more power from this setup. So yeah, as you can see, this is still the same thing. We have a motor right here, and then this is what is on the inside of this. So a set of gears, and then Yeah, no problem, man. No problem. Okay, so we're gonna screw this in down into the wood. We're gonna drive this into the wood so we have a stable connection. All right. Let me get my. Okay, that's coming out. Chucky says hi. Hello, how are you doing? So guys, if you like this, if you're enjoying this, you can give us a like, or you can as well subscribe to the channel. Thank you so much. All right, so let's just get this in right away. And all right, now that isn't straight. Let's take this out first. Well, anyway, that is just to hold it. Well, it's out again. So, okay, let's get another screw. All right, I think this one's way too big, so I don't think there's a hole in here. Well, anyway, let's just, well, so as you can see here, this is our connector. We're just going to hook up the capacitor right here, which this is our capacitor to smooth the voltage. All right, so let's hook this up into the connector. So not with this, but with this. All right, there we are. All right, and screw that down. Okay, and this. So I forgot to add that we are actually, so this is what happens. As you can see, the battery's hooked up, and at the moment, it's acting as a normal motor. So when I turn on this, it's gonna reverse itself back to a generator. As you can see, the voltage on the emitter is increasing, which indicates that the battery is charging. So, but a way to charge this more efficiently is using a diode, so that we don't, so that the voltage from the battery doesn't go into the motor and consumes the power of the battery. So, as you can see, it's increased from 4.1 to, sorry about that, from 3.52 to 3.79. Yeah. Okay, so we've hooked up the capacitor, and now we're gonna connect. We're gonna hook the generator down here. So we're gonna need extra wires. All right, I think I'm running out. All right, here it is, extra wires. So like I said, guys, if you want to hook up a capacitor to any gadget, or you're working on a PCB and you want to replace a capacitor, you want to be really careful by replacing it in the correct polarity. Like as you can see here, this capacitor has a minus sign. That is there to indicate that, hold on a sec, let me show you that right away. So this sign here is there to indicate that this terminal here is negative. So you want to hook this up to the negative, or else the capacitor is going to blow up if you power the PC. So you really want to be careful if you're replacing capacitors. So right here, this sign right here is negative, as you can see, and the terminal here is negative. So at this other side, we have absolutely no markings to indicate. So right here is our positive. Right here is positive, and here is negative. All right, so you really want to be careful when connecting, replacing capacitors. So that's what it is. So now we're going to hook up the generator to this capacitor. So now we're going to look for the polarity of this generator. Well, it's really simple. You can use your multimeter or you can use an LED to do that. So let me show you that right away, guys. A way to know the polarity of anything that generates electricity, you just have to hook your multimeter correctly. As you can see here, I've got the positive probe of my multimeter at V ohms, and I've got the negative, which is COM, as you can see there. So now if we connect this in a wrong way, it's going to indicate on the multimeter that it's going to show a negative sign as an indication that that is a wrong connection, a wrong polarity. So here's how it is. Let me show you that. So by doing this, we're able to know which is negative and which is positive. So let me show you that right away. Nope, let's use, okay, it's okay. Let's use here because that is generating a lot of voltage. As you can see, it's indicating negative, guys. As you can see there, as we turn, it's indicating negative. But this generator can generate electricity in forward and reverse. And in forward, the polarity on the terminals here is going to change. Let's say we have positive here and negative here. So if we turn this forward, it's going to generate electricity, negative and positive. Okay, yeah, negative and positive. But if we reverse it, it's going to be positive and negative. All right, don't even understand that. Okay, so just watch the meter. So right now, this here is negative, as you can see. But our meter here is connected. This probe is connected here. But if this was positive, if this is a wire from the generator. If this was positive, hey, what's up? Carman, what's up? So if this was positive, you wouldn't see a negative sign. So when I turn this back, as you can see, there's no negative sign, which shows that this point of the generator is producing positive. Right now it's positive here. But when I turn the other way, as you can see, it's negative. But when I turn here, it's positive, as you can see. Okay. All right. So, and also the battery can also tell us its polarity. Let me show you that right away so you can see what I'm talking about. So, okay. Connect that there and connect this here. As you can see, guys, right now, you can see the direction where the motor is turning right now. So if I turn this way, we're going to damage the battery. So I'm going to have to turn it in the direction where it's actually turning. That's where I'm going to turn it. So that is going to charge the battery. So watch what happens to the battery when I turn it that way. So we're going to hook up the multimeter again. Okay. As you can see, let's stick that right up here. Okay, let me stretch a little bit. Right here, 3.52 volts. So watch what happens when I turn it in the direction where it's turning at the moment. It's going to increase the voltage. As you can see, 3.52 volts has been increased to 3.69 volts. So watch what happens when I turn it the wrong way. You see what happened, guys? Yeah, the voltage, it reduced the voltage of the battery so a bit. So watch that again. As you can see, it's actually draining down the voltage. But when I turn it in the correct way, it's going to charge the battery. All right, so yeah, let's hook up the battery and the generator to this capacitor to smooth the voltage when we're charging. Right, so we're gonna connect this, open this connector and fit in. As you can see here, guys, we've got positive, which is this wire here, which means this is positive right here. So we're going to hook up the positive of the battery and the generator to the positive of the capacitor. And plus my multimeter is connected there. So, all right, let's do that. And this, whoa, okay, it stopped. So let's check that again. Not good, not good, not good. Wait a minute, we have a problem. Oh, great. Great, great, great. This isn't good. So the thing is, this connector, I was wrong about the connector. So what happened here is this 2 points are connected. If we tune our meter knob to the continuity, it's going to read continuity on these 2 points to show that this 2 points is connected. So we did a wrong connection here. So it's going to be, I'm going to have to take one of the terminals and connect it here. So let's do that. Nope, this guy isn't going in. So we're going to take this out and connect this right in. First, we're going to put it in there and, all right. Open this up. Well, we have a lot of problems here. Anyway, guys, I think we should use a bigger capacitor. This one has little legs, and it's really hard to connect wires and this stuff. So let's hook up a large capacitor. All right. Alright guys, let's see if this generator can actually... Hey, what's up? What is going on here? So what's going on here is we are setting up this generator to charge lithium-ion batteries. This is a really simple setup of just a set of gears connected in this, connected like this, hooked up like this. So what happens is when you turn on this gear, it spins the last one really fast, and then the motor that was here, it turns out really fast, and then we're able to generate about 40 volts and 3 amps. So will it power my flux capacitor? I need to get back to 2075. Okay, holy, 2075, that is really long. So will it power my flux capacitor? I need to get back. Okay, time travel. We've got a time traveler here. No, this isn't gonna power your flux capacitor. You're gonna need a lot of power for that. All right, so let's try and power this up. Let's see who's gonna actually power this. I don't know how many volts. It's not indicated here. It's just the wattage, 12 watts and not much. Just all right. Anyway, so just see if this generator is gonna actually power this AC bulb. Not really AC because it has a. But anyway, let's just see that. Let's connect this like this. Well, I don't know the polarity, but let's see how it's gonna go. Nope. Nope. No, it's not. I think this bulb isn't working. Let's see. Let's try something else. Let's hook this guy up. Try something else. Let's see. I think I have a set of LEDs later on there somewhere. Okay. This generator will damage. Hey, how's it going? Let's see. At 3.5 volts, I don't think so. No. This isn't. This generator generates more than 3.5 volts. It's about 40 volts. So I think the reason why I didn't turn on was because of the. I think the LED is bad or something. So, oh, show the face. Show the face. Actually, no. My face? Can you? Can I do what? All right. Trying to see if I can find some LEDs. How much voltage needs to move? My face? Why should I show my face? I mean, we're here for the generator, right? Oh, you're saying how many volts does this LED need? It's not indicated here. You're curious. I don't know. Maybe some other live stream I might show my face or something. Oh. Remain anode, dude. You want to be able to go to the store when you're powering the grid with Blink Power 2.0. Okay. Okay. Actually, I think that's, let's see, nope. You know, I had a large generator that could actually power this bulb. I took it out from a washing machine, but I sold that out because I needed some money to finish up my project. So, um, you know this washing machine, the inverter washing machine, the one with a solar a motor. I think it has a phase, and you can actually generate a lot of voltage from that stuff, and it can literally can power this 100 watts AC bulb. Really good. Do you just have a garage full of random stuff, or is this your job? Yeah, this is I do have a garage full of random stuff. Yeah. So, oh yeah. Let's power this. Yeah, let's power this LED up. Let's power this one up. This back of LED. Let's see who's gonna turn this on. This is 3 volts, and this is gonna need a lot of power to turn on. So let's drop that right here so you can see. And let's connect the alternator. RC Toy says hi. Hello, how you guys doing? So let's connect this to this really powerful LED and see if it's going to turn on. So this is B plus, B minus, which is the battery. We're going to hook that up to the generator. Let's see if it's going to turn on. So let's do that and connect this. So now we're going to turn this with our hand and see if that's, no, not that way. Or my, oh, it's not going to turn on because of the IC. So what's going on is when the IC senses a fluctuation in voltage, it's going to shut down the whole system. So I think that's what's going on here. So the way to bypass that, I'm going to bypass that by doing this. Let's see. We've got negative. Let's see. Let's use our multimeter. Let's bypass that immediately so we can show you how this is. Right. Hook that up here. I think. Let me just open up this copper strip. Okay. Right. Peel this off a little bit, and we're going to test. So what we want to do is bypass this so we're able to turn it on first. Okay, that's it. Okay, that's connected, and let's try out this. Let's see. Okay, Morty says you can plug in a capacitor. Yeah, of course. And Golden Arrow says lighting as many candles as possible in the house after closing the door reduces air pressure. Well, that's a good idea. Yes, absolutely. Absolutely. It reduces air pressure when you light up the house with a bunch of candles. No. Lighting as many candles as possible in the house after closing the door reduces air pressure. So actually, heat creates pressure. It doesn't create a suction or a vacuum or anything. So it's only a cold environment that does the reducing of pressure. So I don't think that's it. So anyway, let's just bypass this and power it up with this generator to show you guys how powerful this stuff is. Cold candles is what we need. Cold candles, absolutely cold candles. And where in the world are we going to find cold candles? Yeah, I think we can mine that from. I think we can actually mine that in Minecraft. I think I'm going to try that out. All right, so anyway, Iceland, yes, yes. here. Let's see. Okay. Let's see this transistor here. Nope. Nope, not there. How about a diode? No. Okay, let's just test this with the battery and know which one is which. So, negative. We're gonna bypass this. Really simple, really quick. Let's just find where we're supposed to connect. Nope. Okay, let's try something else, guys. Let's try, let's see, I don't know, I tried this once, but I don't know if this generator, I think this generator actually damaged this cooling fan. Charge a vape. Charge a vape. I don't use a vape, man. I don't do any of that stuff, man. I don't smoke, so. Let's just try this fan out. Let's just try this cooling fan, man. Okay, let's see. No. No, so I actually damaged this fan, this cooling fan I think that was last week. I turned this in the wrong direction and blew the sensor, the Hall effects sensor. So I don't know where put my LEDs. Okay, let's power this LED up and destroy it. Okay, guys, I found something. I think I've used this before in this video. Yeah, let's power this guy up. All right. Gonna take out the LED. So, yeah, I'm gonna shock you now, man. Let's show you how powerful this is. So I've actually done this before. So, and let's power this up and okay. Let's see. Woo! That is super bright. Okay, let's do that again. Whoa. That is super bright. I want a Tesla coil. It would really annoy my neighbors with their cheap, soaked up cars. They run at 11 p.m. Okay, yeah, I get it. I get it. It's gonna interrupt the system. So shocking is good as long as there are no amps. Yeah. Oh, I don't want to damage this LED, guys. So Tesla Coil can actually mess around with some electronics, like let's say sensitive electronics, like uh, let's see, I think more sensitive with more sensitive microcontrollers and stuff like that. So, how to make that? How to make what? What exactly? Oh, that is super bright, guys. Super, super bright. Oh, what I'm doing, it's really simple. It's really simple. All you need is just a set of gears like this. So this is what is on the inside of this guy right here. So it's just a set of gears like this, a large gear and a much smaller gear. As you can see, the large one with many teeth as you turn. As you can see, at the other end, it's much more faster. So, and at this point, we have a motor that's sitting there. As you can see here, this is the motor. This is where the gear is, the large one, the much smaller and much more smaller gear. And then it's turning the motor really fast, and the motor is generating 40 volts, with just turning with my hand, guys. 40 volts. So imagine what will happen if I hook this up to a bicycle and paddle it. I mean, that would be crazy. I can actually charge my phone and stuff. I've used this to charge my phone, but not really effective. I got about just 2% charge. So yeah, this is gonna do really good if you hook it up to a bicycle. So as you can see, it's working. This is awesome. Do you have videos that show how to do this stuff? Yeah, I think I have about 2 videos on my channel. You can go ahead and check out my channel. I have about 2 videos. Hey, what's up? Ojo. All right, so yeah, it's a really simple setup. Anyone can do it. All you need is just a set of gears like this. And all right, thank you so much. Subscribe. Thank you so much. All you need is just a set of gears like this. Thank you. A big gear, if you have one, you can just, or you can 3D print something like this and use it. As you can see, just a slow rotation, guys. And at this end, it's really fast. Hello, Michael. And what happens at this point is if I turn, it increases the torque, the strength of the gears. So as you can see, I can use one finger. I mean, I'm holding it really strong, but I can use one finger to actually turn it, as you can see. Okay, Savage says 24 40K RPM motors on 36 volts is really fun. Yeah. Yes. I mean, if you're generating electricity, you want a motor that generates electricity at a really low RPM, just like a three-phase, I think a brushless alternator, a permanent magnet brushless alternator is going to do that really, really good. By just turning it really slow, it generates a lot of electricity, and those are from a power wheel. Yeah, yes, definitely, yes, absolutely. When I turn it this way, it's really free because it has changed its polarity. So, and at this point, oh, that is super bright. I need some glasses for that. Oh. Okay, let's try powering this motor right here, this little motor right here. You have a great day. Okay, this has been cool. Thank you so much, Andy. Thank you. So let's power this little motor. This was a vibrating robot I built for my little friend. Okay, I'm retired structural welder. use electricity every day, but don't know nothing about it like you, Lo. Yeah, you can always learn, man. I mean, I also learn a lot of this stuff on YouTube and, I mean, some books. So, yeah. Hello, how you doing? Okay. Yeah, seriously, man, you can always learn this, huh? It doesn't matter the age, man. You can always learn this stuff on YouTube if you're really interested in it. If you have a passion to drive. Yeah, I got it. How did you hook it up to the motor? How did I hook it up to the motor? Hmm. How did I hook it up to the motor? I don't understand. Right? So let's hook this, let's connect this little guy to the generator right here and see what happens. Okay. How does the motor fit in that plastic piece with gears? Okay. So let me grab the one that was actually here before. I can't find it, but okay. There's some screws in here that is used to hold the motor together. The motor here. So it goes in here, and there's two holes. We have some screws right there. Love a bit of tinkering. Hey, thank you. Nice. The light that you are powering up to the motor, how did you hook it up, negative and positive? Yeah, you don't really need to find, since it's a DC motor and it changes polarity when you turn it clockwise and clockwise. All you need to do is you can just hook it up, and if you turn, you can turn the other way. Let me just do that right away and show you. Or you can always use it one time to find the polarity, the positive and negative. So let me show you that right away. Okay, so at this point, as you can see, the LED is not turning on because the positive and negative are on different sides. So watch what happens. As you can see, it's not turning, it's not coming on, but watch what happens when I turn it the other way. As you can see, it's on. Well, that's because it's a DC motor. Hello, how you doing? So let's hook up this little robot. Okay, let's see if it's gonna move or anything. DC direct current. Direct current, guys. That's DC. All right. Whoa. Let's do that again. Yep. It's actually camera quality is potato. Yeah, that's because it's live stream, and also I'm using only one light, so yep. Whew. DC direct current is used for stick welding, also known as SMAW, shield metal arc welding. Yes. I mean, with DC, your welding is going to be more neat than AC. I think I've done a test on that before. I've done a test on that before. place it right there. Turn the camera right here. Let's do that again. Okay, guys. Well, that was powerful. And set it right here again. I mean, this is a really simple robot you can build for a kid, for your child or something. It's just a vibrating motor. All you need to do is put in a flywheel and let one side of the flywheel be heavier than the other side. Good to go. Okay, right? What is that gear ratio? Well, that is what I do not know. I mean, but you can always experiment on your own and find something out. So that's what I don't know. So U equal to I, okay. Dayton boron. U equals to I dot R. What is that? Oh, ratio. That is super powerful. That's super powerful. All right, let's. Okay, Intelligent Thinker says, if you have a permanent marker, put 2 dots on first gear and last gear, then you can count the revolutions. Yes, but I don't have the, how is it called? Come on. How is the meter called? The one that is used to measure speed. How is it called? I forget a lot of things. Oh, but you can actually count that without the meter. Yeah. Yeah. So we're gonna need a marker. Just place like a dot or something. Then you let it rotate, and then you count the numbers of revolutions. So does that have any like formula to actually know the ratio? When I'm done counting the revolutions, is there a formula for that? Okay. All right, guys, let's hook up a diode and actually charge this semi battery. Let's charge it to 4.2 volts. Okay. Intelligent Thinker says there's actually a formula for that. You got it. Thank you. Okay. And turn on. So guys, if you have any questions, you can always ask. It might be 50 to 1. Oh, you're talking about this very one, right? So that's the ratio of this big guy. Alright guys, I'm back. So, okay. Hello. Oh hey. So this is a generator. I'm using this to charge lithium-ion batteries. It's a really simple setup with gears hooked up in series. I said series. All right, so yeah, that's what it is. It's a generator. Well, that's nice. Well, thank you. So let me explain this more. This is just a simple setup with gears like this, so you can see what's going on. With just a little rotation here, where at this point it's spinning really fast, as you can see, and the motor is sitting here. The motor is just a DC motor that generates electricity when you spin it. So if you turn on that, you're able to generate electricity. About 40 volts we're getting from this guy. So that's what it is. Okay. Put you right there so you can see.